Welcome back to Applied Mathematics. In this video, I want to introduce you to linear regression. We've previously done some work with linear models, something that we can write in an equation in the form like y equals mx plus b. And we've seen that if this model represents some real-world phenomena, we can analyze it. We can find the slope of the linear model. We can talk about what that means. We can talk about the y-intercept at the point 0b. We can talk about the x-intercept. And we can try to apply some meaning to that and extract information out of the linear model. The natural question that follows from that is, well, how did we get the linear model in the first place? There are a couple of different ways that you can approach that. Very often, the linear models that you're studying in courses at this level are all built around some strong theoretical underpinnings. We have some theory. If we work with the theory, it generates this model. We now have the model. We can do more with it. But very often, you're looking at a situation that no one has studied before, often because no one has thought to study before, or no one has taken the time because it's not that interesting in the large scheme, right? No one has studied the effects of water on my front yard because, well, it's my front yard. No one cares about my front yard except for me. So if I want to construct a linear model to discuss how water is running in my yard, I need to collect some data and then try to analyze that data. It's possible to do a lot of these tasks by hand using pencil and paper, but we live in the digital age. Let's let computers go ahead and do that for us. So here I am again on the website Desmos, and I want to do some modeling of data. If I click on the plus sign on the top left corner of the screen, you can see that it's the Add Items button, and it gives you a couple of different options. We can add an expression, we can add a note, and the one we care about is we want to add a table. A table is going to let us plot points. And then we enter in whatever x values we've come up with and the y values that match that. Again, what these mean is entirely based on the thing that you're trying to model. But let's just put in a couple of numbers. So we have the 0.35, let's have the 0.56, and how about 7.7? There's 3 points. 2 points gives you a line, 3 points will make the line a little bit straighter. And at this point, I think I need to get my head out of the way so that we can focus on what's going on behind me. In this table, you should notice the headings, sorry about that, the headings are labeled as x1 and y1. You could change those names, you can change the names of those variables if you would like. Don't just call them x and y, because if you try that, Desmos will do some really weird things. I also noticed that all of this data is up in the first quadrant, and so it might be useful to kind of move the graph and zoom in a little bit so that we have the data a little bit more clearly distinguished. Then I'm going to give the command for Desmos to construct the linear regression. I want to type the y variable, which in this case is y subscript 1. Y is easy. Subscripts are a little bit harder. In order to write a subscript, we want to type the underscore character. And when I type underscore, instead of it displaying an underscore, you can see that the cursor moved down and is now allowing us to type a subscript, where I'll type the number 1. To get out of the subscript, I'm going to hit the right arrow key, and that comes back here. If I said equals, then Desmos would try to treat that equation as something that it should know about. And that's not quite what I want. I want Desmos to figure things out for me. And the key for doing that is the tilde key. Tilde key is on a standard keyboard layout to the left of the numeral 1. You'll probably have to hit shift to get that. But then I wanted m times x, and it's not just x. In my table, it is x subscript 1. Let's get out of that and type in our plus b. So that's y equals mx plus b. We've used a tilde to type this so that it is telling Desmos we want it to do some calculation. And it's using y1 and x1 to tell Desmos that we want the data right out of the table. And you can see that the line has been immediately drawn. If I click off of that box, it will make the line a little bit less bold. And if I come back to the table, it should highlight those points so we can see clearly that all three of those points ended up on the line. Now, if you look at the parameters that have appeared when we typed this out, we've gotten four of them. We have m equals 0.5, b equals 3.5, r squared equals 1, and r equals 1. They've also got this thing called residuals that allows us to plot them. We'll talk more about residuals a little bit later. They're kind of an error check. They're a sanity check for you to use to verify that the thing that you're graphing is in fact a linear model and it shouldn't be used using something else. The r and r squared values are a measure of how well the line fits the data. And you can read that as a percentage. In this case, we have perfect data, so our r squared is 1 for 100%. But the most important numbers are the value of m and the value of b. So, if I want to use this model, I will write down exactly what that's giving me. I know that the equation is generally y equals mx plus b, and if I jump over here, I can write my y equals my m value was 0.5 times x plus my b value, which was 3.5. And that's the equation of the line that Desmos has drawn for us. That's it. That's all it takes. The computer does all the work for you. I apologize, a bright screen warning here, because the next thing I want to do is jump over to a spreadsheet. So here you can see I am in Google Sheets and I have some data that was given to us in a spreadsheet. I'm simply going to highlight all of that data and I'm going to hit Control-C on my keyboard for copy. Then when I move into Desmos, let's get the old stuff out of the way, and I go into that box, I don't have to create a table, I don't have to do anything else. I've copied data out of a spreadsheet, and when I hit Control-V, it gets pasted in, automatically interpreting that that data is a table and we want to see the plot. Let me get my head out of the way so that you can actually see this plot. We've gotten several more points than what I had before, but it's still the same basic idea. My table is still labeled as y1 and x1, so my regression line is still going to be y1 tilde m x1 plus b. And there we have our line for the data that we grabbed right out of a table. A quick thing that I want to point out here, this graph has a negative slope, and that weird thing with r and r squared, that's the way I want to point. The r value here is suddenly negative. The value of r will be positive or negative depending on the slope of your line. Positive slope, positive r, negative slope, negative r. That's the reason that a lot of people like the r squared value instead, because when you square a number, whether it was positive or negative to start, the result comes out positive. All right, let me get my head out of the way. Let's get this table cleared one more time and go back over to my Google Sheets file where I have another set of data already prepared for us. When I copy this data and paste it over here, first of all, notice that Desmos has automatically rescaled when I pasted in data to make sure that all of the data appears on the graph. The other thing that I want you to notice is that for the first time in what we've been doing today, that data doesn't really look like a straight line, does it? And that's okay. In the real world, data is messy. So you're never going to have a perfectly straight line. And that's one of the things that regression is the best at. The regression analysis technique that is programmed into Desmos is automatically looking at the messiness of the data and trying to find that best fit curve. So some of the data points are high, some of the data points are low, but on the balance, they are all clustered around that line pretty nicely. That's what we're looking for here. That's the kind of results we're looking for. Because it's not perfect, you can see that my R value is no longer 1, it's slightly smaller. This is still pretty good data. We've got 99% fit instead of 100% fit. I'll take that. But because my data is a little bit off, I can finally get some meaning in these residuals. So if I go ahead and hit plot the residuals, you can see that there's a new set of data that has shown up on the table. It's called E, and it's graphed in yellow, and it's right near the x-axis. What I want you to notice in this data, in the residuals, is that it kind of appears random. Some of the points are above the x-axis, some of the points are below the x-axis. There's not much rhyme or reason to it. If the residuals are random, then you are in good shape with your choice to graph the line as a linear regression, or to use a linear model to represent the data. If there was a specific pattern to the residuals, that would give you a little bit more trouble. That's usually a sign that linear regression probably wasn't the best choice. We'll talk a little bit more later on in the course about what to do when your data is not appearing linear, but for right now, I think that's a good place to stop. We're able to get data into Desmos, we're able to allow it to generate the regression line for us, and once we have that regression line, we're able to extract the useful data and write it down. I guess one last thing I should mention is use your accuracy and precision rules for rounding when you're copying over the M and B value the same way you do when you're trying to continue on in your calculations. For example, in this particular set of data that we're plotting, all of my parameters have 2 significant figures, so I would probably round M and B to both have 2 significant figures to match when I'm trying to write this down. That's really all I have on this one. The computer does all the work. You just have to know how to tell it to do the right thing at the right time. So with that, I'll wrap up. As always, thank you for joining me, and I'll see you next time.